Hello everyone. In this video we're going to be solving a really nice math problem, an exponential equation from Wisconsin. Speaking of Wisconsin, I have a friend who is a professor in Wisconsin and he wrote a lot of books. I'm going to share some links down below so you can go ahead and check it out. But anyways, we have this equation x minus 3 to the power 2x minus 6 equals 1, and we're going to be looking for x values. Of course, we're looking for real values, not complex values, because I have another channel that is dedicated to complex numbers, and the channel is called aplusbi. Also make sure to check it out. All right, let's go ahead and take a look at how we can solve an equation like this. So we can look at this equation in different ways. Let's go ahead and do the following first. Since we have an exponential equation and this is a variable, it would make sense if we log both sides. Which base should you use? I don't think that's a big deal. We can use base 10, which is log. So let's go ahead and log both sides. Log x minus 3 to the power 2x minus 6 equals log 1. Now, by log, some people mean the natural logarithm, but I'm not one of them. I just use it for base 10. Okay? So properties of logarithms tells us that we can go ahead and move this to the front. So let's go ahead and bring it up here to x minus 6, and that'll be multiplied by log x minus 3. And as you know, or you should know, log 1 at any base, of course 1 can't be a base, it has to be between 0 and 1 or greater than 1, it's 0. Great. Now this is super helpful. You know why? Because this kind of gives us like two factors and the product is equal to 0. So what is that supposed to mean? It means that each factor can equal 0. Doesn't have to, but either or, right? So 2x minus 6 is equal to 0 will give us, obviously, 2x equals 6. And from here, we get x equals 3. Awesome. What else? Well, we can also have log x minus 3 equals 0. And what is that supposed to mean? Log x minus 3 equals 0. Now you got to remember, and again, the base doesn't matter here. You can use the wrong base. But let's just say it's 10, as usual. So from here, you can use the definition of logarithms. So this means 10 to the power 0 is equal to x minus 3. In other words, x minus 3 is equal to 1. So you should know, at any base, log of 1 is always 0. Okay? And x minus 3 equals 1 means what? It means x is equal to 4. So far, we got two solutions, didn't we? Okay, here's the problem. I mean, some people think this is a problem. I don't, and then my friend will probably disagree with me on that because he's a math professor, and you know professors are, they have to be rigorous and this and that. Anyways, that's a different story. We'll see what happens. But so far, we found these. Obviously, a good idea is to take these x values, plug them in, and check against the original problem. So let's rewrite the original equation. X minus 3 to the power 2x minus 6 equals 1. And I think the competition that I took this from was Wisconsin Mathematics League, if correct me if I'm wrong. Anyways, so if x is equal to 3, Houston, we run into a problem. And that is 0 to the power 0 equals 1. I know a lot of people are going to object to this and they're going to say, oh no, 0 to the power 0 is indeterminate, undefined, this, that. Okay, and I made a video about this, so you can actually go ahead and check it out here. I prove in 3 different ways that 0 to the power 0 is equal to 1. And we're going to look at the graph. Actually, correct me. I hope I included the graph. If not, then go ahead and Desmos will give you the graph. But I strongly believe, but not just believe, it's not a belief, like I know that 0 to the power 0 is equal to 1. Okay, anyways, so that means for me, x equals 3 is a valid solution. What about the other one? Well, there's nothing wrong with that. If x is equal to 4, from here, if you plug it in, you're going to get 4 minus 3, which is 1, to the power 2, obviously, that is equal to 1. No question about it. We'll all agree, right? So x equals 3 and x equals 4 are two solutions. But are those the only solutions? That's a good question. Because when you log both sides, you're kind of changing the domain of the function, okay? And what do I mean by that? the possible x values will change. Why? Because when I say something like log of x minus 3, then in that case, I'm assuming that x minus 3 is greater than 0, because log only accepts positive values, at least in the real world, right? If you're interested in the complex world, that's a different story. I already told you about it. But as soon as you write something like this, in order for this to be well-defined, x minus 3 needs to be greater than 0. But then that means x needs to be greater than 3, so we should reject x equals 3, right? Well, the original equation didn't have a log. We just invented it. I mean, we didn't invent it, but you know what I'm talking about. We just introduced a new thing. So just like squaring both sides in a quadratic or radical equation, we introduce extraneous solutions. Extraneous means they're not solutions of the original problem, but they are solutions of the problem that we came up with after doing some stuff, right? Like squaring both sides or other things like logging both sides, because it changes the domain. Cubing both sides, it doesn't change it, right? But these operations do. So we kind of have to be careful. So what we need to do then is maybe go back and look at this equation from another angle. By the way, we can go ahead and call this method the first method by logging both sides, and the second method is without logging both sides. How can we do that, right? Let's take a look. So we have this equation again from Wisconsin. Thank you for this problem. And we can actually go ahead and look at it this way. If x is a real number, x minus 3 and 2x minus 6 are all real numbers, so we have something like a to the power b equals 1, where a and b are both real, then how can we get 1 from here? What are some possibilities? And there's actually 3 possibilities, right? One of them is, okay, a can be 1, then we don't really care about b, it can be anything. Second scenario is a can be negative 1, and b can be an even integer. And of course, we have to have an and, because if one of them is not true, then we have a problem. And the third case scenario is b equals 0. And I know some books or some people will tell you, and b does not equal 0, but I don't have that requirement. Like I said earlier, 0 to the power 0 equals 1. Are you convinced? If not, go ahead and watch the video and let me know what you think in the comment section down below, okay? So we're going to be looking at all these cases. Let's number them, number 1, number 2, and number 3. Let's look at case number 1. A is equal to 1. A is the base, remember? It's kind of weird. B can probably be used for base, but anyways, x minus 3 is equal to 1, and we don't really care about anything else, which means x equals 4 is a valid solution. We found that before, right? Great. Second case, a is negative 1. So x minus 3 can be negative 1, and from here x becomes 2. But you have to check to make sure that the exponent 2x minus 6 is even. But guess what? 2x minus 6 is always even because it's a multiple of 2. Don't you see that? Therefore, this is always, 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 always even. Obviously, if x is a fraction, that's a different story, but here x is an integer. Therefore, x equals 2 is also a valid solution, which is interesting because we did not find it with the first method. You see, that's the shortcoming of logging both sides. And then the third case is where we set the exponent, which is 2x minus 6, equal to 0. And as you know, from here we get x equals 3, but we also get 0 to the power 0, but who cares, right? At least I don't. And this brings us to the end of this video. It looks like I forgot to include the graph. It has an interesting graph, actually, because you know when you graph it, you're going to see some dots. But definitely try to graph this function, f of x or y. Let me put that here. X minus 3 to the power 2x minus 6 with Desmos, desmo.com. And then you're going to see an interesting graph. But don't zoom out or zoom in, because you're going to see some dots. And let's talk about what that means. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out SyberMath, the Shorts channel, and aplusbi. And bye-bye.